Hi there, time for some more chemistry. So today, we're going to be taking a look at displacement reactions. Now, displacement reactions, also known as replacement reactions, are a type of redox reaction. You should recall from before that a redox reaction is when that oxidation number is changing as a result of gaining or losing electrons. If you don't remember much about that, you can go back and take a look at that video that we did before, where we looked at examples of magnesium burning, combustion, the rusting of iron. All those are types of redox reactions. So without further ado, let's jump into displacement reactions.
So just a quick reminder before I continue on with our new topic on displacement reactions. It's important to remember that the strength in using videos like this one, when either learning new material or reviewing older topics, is that you can always pause and rewatch portions of it that you're not completely comfortable with. Also, you should make sure that you're ready to pause the video when prompted, such as when you are asked to answer a practice problem. We're going to start with some vocabulary, so be ready to fill in the section on your flipped classroom handout. So, that's it. Let's get on to it. So, a displacement reaction is a reaction in which an element is displaced or replaced by a more reactive element. This is a redox reaction. We can use the metal reactivity series to determine if a displacement reaction will occur or not. So here you can see some copper powder that has been added to some silver nitrate solution. When the copper is added to the solution of silver nitrate, the copper will displace the silver from the solution because the copper is more reactive than the silver in the silver nitrate. This allows for the displaced silver to form a solid precipitate that you can see at the bottom of the test tube. So metals can be organized by their reactivity compared to one another. This organization is called a reactivity series. Working our way up from the bottom of the list, at the very bottom we have platinum, which is the least reactive metal shown in this list. Moving up in increasing reactivity, we have gold, silver, copper, lead, iron, zinc, aluminum, magnesium, calcium, sodium, and lastly, potassium. So potassium is the most reactive metal on this particular list. You'll be generally given a copy of this chart, so you don't need to memorize it completely. However, it's probably a very good idea to have a general knowledge about the types of metals that are very reactive at the very top, such as potassium and sodium, and the least reactive towards the bottom, which are some precious metals like silver, gold, and platinum. All right, so getting back to displacement reactions and making the connection between those and the reactivity series that we're just looking at. An element higher in the reactivity series will displace an element lower than it from a compound. So the more reactive element will take the place of the less reactive element. An example of this would be we are reacting a piece of zinc metal along with copper sulfates. The zinc being more reactive will displace the copper. So we will get zinc sulfate in a copper precipitate. Looking at the reactivity series, we can see again down here is copper, and up here is zinc. So towards the top is more reactive, so zinc is more reactive than copper. So zinc is going to displace copper. That can be written out in the word equation as zinc plus copper sulfate yields zinc sulfate and copper. And this is the chemical equation for that. It's also important to remember that this is a redox reaction, which means that we should identify what is being oxidized and what's being reduced. So because zinc is losing electrons, it's becoming positively charged, it is being oxidized. And because copper is gaining electrons, it is being reduced. So it's going from a positive charge over here, oops, there we go, positive charge over here, to a negative charge over here. Or not negative, excuse me, a neutral charge. The zinc is going from a neutral charge over here to a positive charge here because it is losing electrons. So again, that means that zinc is being oxidized and copper is being reduced. When in doubt, don't forget oil rig. And remember that again, that is oxidation is the loss of electrons and reduction is the gain of electrons. So moving on, an element higher in the reactivity series will not be displaced by an element lower than it. So the more reactive element will stay as a compound. So for example, if you add a solid metal copper to a magnesium sulfate solution, the copper will not displace the magnesium. You can see in the reactivity series here that copper is again towards the bottom here, and magnesium is towards the top. So the copper down here cannot displace the magnesium. There will be no reaction. So one other important note is that so far we've been talking about single displacement reactions. That is when there's only one metal being displaced from a compound. There are also double displacement reactions. And simply put, this is when there's two different ionic compounds and both the metals in those ionic compounds are swapping places. Now, we'll come back to that a little bit later in class, but for now, let us stick to single displacement reactions. All right, so to summarize and give a more simple equation that we can use for displacement reactions, specifically single displacement reactions, let's take a look at a previous example and break it down a bit. So we now know that a solid zinc metal will displace a copper metal, forming a new compound of zinc sulfate and leaving the copper to form a solid. So we can generalize that even further as metal A plus metal B compound forms metal A compound plus metal B. But we can take even one step further and just use letters. And this is very common. So simply put, A plus BC yields AC plus B. A, of course, is the more reactive metal, and B is the less reactive metal. And C is simply that anion of the compound. So we want to make sure that these equations are on your handouts because we're going to be doing a couple quick practice problems next. So get ready. All right, so here's your first practice problem. Complete the following reaction. A piece of solid magnesium is placed in a solution of iron nitrate. Please write the full word equation down here. And for extension, write the balanced chemical equation, including which metal is being oxidized and which is being reduced. So remember, oil rig, oxidation is losing electrons and reduction is gaining electrons. I'll even go ahead and give you a reactivity series to help you out a bit. So pause the video and complete the equation in your practice problem section of your handouts. Pause now. Resuming in 3, 2, 1. All right, so looking at the reactivity series, we see that magnesium is up here at the top, and that iron is right there. My circles are a little bit off there. All right, so we know that magnesium is more reactive than iron, so there should be no problems with it displacing the iron. As we can see, that is the case. Magnesium will react with iron nitrate to form magnesium nitrate and iron. That can be written. This is the balanced equation as well. So magnesium reacts with iron nitrate to form magnesium nitrate and iron. Magnesium is being oxidized and the iron is being reduced. All right, so next we have a solid metal of lead being placed into zinc nitrate. Using the reactivity series, please complete the word equation and the appropriate balanced chemical equation. So please pause now. Please resuming in 3, 2, 1. So looking at the reactivity series, we can see that solid lead, or lead, is right here, and that zinc is up here. So again, lead is less reactive than zinc, so lead cannot displace zinc. So we get the same products as reactants, so there's no reaction. So simply that, there is no reaction. Okay, last practice problem. Complete the following reaction. A piece of solid zinc metal is placed in a solution of iron nitrate. Complete the word equation, and you should also try to complete the balanced chemical equation, along with the reduced and oxidized metals. So, pause the video, because we're resuming in 3, 2, 1. Okay, so looking at the reactivity series, we can see that zinc, right here, is more reactive than silver. So zinc will displace silver, as we can see here. So it can be fully written out as zinc plus silver nitrate yields zinc nitrate and silver. The chemical equation would be zinc plus silver nitrate yields zinc nitrate plus silver. And in this case, the zinc is being oxidized. It is losing electrons. And the silver is being reduced. It is gaining electrons. Okay, time to get over to the lab for some demonstrations. So flip your handout to the back side, this side, for the demonstration portion. And let's head over to the lab now.
Are you ready to make some predictions? Let's do it. So, in front of me, I have 2 copper sulfates, I have a magnesium sulfate, and a sodium sulfate. And into those, we will be placing these metals. So we have 2 pieces of copper, an iron nail, so iron, and a magnesium ribbon. The magnesium and iron will be going into the copper sulfates, and the 2 pieces of copper will be going into the magnesium sulfate and the sodium sulfates. So, at this time, please make your predictions. Hi there, we're back in the lab. We are going to take a look at our results and see if we have any changes. So, let's take a peek. Very interesting. I'm going to flip the camera around so it's a little bit easier to see without my face here. All right, so we have our 4 solutions with metals in them. So let's take a look at the clear ones first. So again, this is sodium sulfate with a piece of copper in it. Give a little stir, see if we can see any precipitate. So again, make an observation, any change. This is sodium sulfate. Give a little shake. We do see some things, but take a look at the metal specifically. We have our copper sulfate with an iron nail in it. Very interesting. Get a little bit of a shake there. All right. And lastly, we have our copper sulfate solution with a piece of magnesium in it. So again, make your observations. Okay, so with that in mind, it's time to fill in your analysis and conclusion portion of your handout. Keep in mind all of your observations and evidence that you have written down to help you create your conclusion analysis. If no reaction has taken place, explain why that's the case. And if there has been a displacement reaction, please write the full chemical equation, and don't forget to include what is being reduced and what is being oxidized. It's very important. Lastly, you need to complete the global concept portion of your handout. Consider some possible uses for displacement reactions outside of the school. You could research methods of fighting pollution or potential reasons why we might want to displace different types of metals from a compound. Good luck and see you in class.